Hello and welcome. In this video we want to do some questions related to the tangent line to a curve. Before I show you how to solve these questions, let me remind you the tangent line. What is the tangent line and its properties? Consider this curve. Suppose this is the curve of a function. And let's say we want to find the tangent line at this particular point here. Let's suppose it's A, the x coordinate is A and the y coordinate is B. If at this point I draw the tangent line, this is the tangent line to the curve y equals f of x at the point P with coordinates A, and let's see what is the relation between the function and the tangent line at this point. First of all, note that this point P is on the curve y equals f of x and is also on the line, on the tangent line. So this point, we name it the tangency point. So as you can see, the tangency point is common between the curve, between the function f of x and the tangent line. So the first property that we have is that at the tangency point is a point that the function and the tangent line, both of them pass through that point, as you can see here. And also the slope of the tangent line then the slope of the curve at the tangency point, at this point, is equal to each other. So a slope of the tangent line and a slope of the curve is equal to each other at the tangency point. So for example, if we have the slope of the line, we have a slope of the curve at that point, at the tangency point. Now that I reminded necessary things about tangent line, let's do this question. If equation of tangent line to a curve, to the curve of the function f of x at the point x equals 5 is y equals 4x minus 13, find f of 5 and f prime of 5. As you can see here, we are asked to find f of 5. But what is f of 5? F of 5 is the y value of the function f when x is 5. And f prime of 5 shows the slope of the function f. As I reminded you, the slope of the curve at the tangency point. At the tangency point is 5. A slope of the curve. So we want to find the slope of the curve, but we know that the slope of the curve and the slope of the tangent line are equal to each other. So if we find the slope of this line, the slope of the tangent line, the slope of the curve is equal to the slope of tangent line. So, but what is the slope of this given line? What is the slope of tangent line? The slope of the line y equals 4x minus 13, as you know, is the coefficient of x here. So a slope of that line equals 4. In general, when we have a line in the form of y equals mx plus b, when we have a slope intercept form of a line, the coefficient of x is the slope of the line. So 4 is the slope of the tangent line. But we know that the slope of the curve and the slope of the tangent line are equal to each other. So because the slope of the tangent line is 4, so we can conclude that f prime of 5 is also 4. What about f of 5? How we can find that? If we plug in 5 as x in the tangent line, we can find the y value of the tangent. Y would be 4 times 5 minus 13. It equals 20 minus 13 is 7. The 7 is the y value of the tangent line at the tangency point. But we know that at the tangency point, which is 5, the y value of the function which we look for is equal to the y value of the tangent line. So what is f of 5? F of 5 is also 7. So let's summarize this question and let's summarize the lesson we learned from this question. At the tangency point, the y value, the x value, the coordinate of the tangent, the coordinate of the tangency point is common between the line, the tangent line, and the function. And also, at the tangency point, the slope of the curve and the slope of tangent line is equal to each other. Now look at this question. If tangent line to the function y equals f of x, at the point 2, 5 passes through point 4, 1, find the value of f of 2 and f prime of 2. So the tangent line to the curve y equals f of x at the point 2, 5. The 2 is the x coordinate of the function and the 5 is the y coordinate corresponding to 2. So what is f of 2? Clearly f of 2 is 5. Look at the given point. This point lies on this function. So when we plug in 2 for x, f of 2, the y value is 5. So this part of the question was clear. But also we are asked to find f prime of the slope of the curve at the tangency point. How we can find that? Remember, the slope of the curve, slope of the function or the curve at the tangency point is equal to a slope of tangent line. Here we are asked to find a slope. F prime is derivative. Derivative is slope of the curve. F prime or a slope of the curve at the point 2. So we want to find f prime of 2. To find f prime of 2, we use this rule. Instead of thinking to finding a slope of the curve, because we don't have function f, how come we can find the slope of the curve when we don't have the function? With this rule, that the slope of the curve is the slope of tangent line. So let's find the slope of the tangent line. But the slope of the tangent line is also not given. We don't have the tangent line. But we know that the tangent line passes through the point 2, 5 and the point 4, 1. And we know that when we have 2 points of a line, let's say this is 1 point and another point, you can find the slope of the second line that passes through these 2 points by the idea of rise over run. So for finding a slope of tangent line, simply we have to find rise over run. y2 minus y1 over x2 minus x1. So the slope of the tangent line is 1 minus 5 over 4 minus 2. This equals negative 4 over 2 equals negative 2. So again, let me review this process. We know that the tangent line at this point, so the tangent line passes through this point, also passes through this point. So the tangent line passes through these 2 points. And when the line passes through 2 points, by finding the slope of the line that connects those 2 points, we can find the slope of the tangent line with the idea of rise over run. So negative 2 is the slope of the tangent line, but the slope of the curve is also the same. I hope you liked this video. See you in the next videos.